Next one is synthesizer. The objective of a synthesizer is to synthesize logical that behaves identically to simulated behavior of the design description. In effect, a synthesizer translates a design description into a functionally equivalent gate level logic implementation. A synthesizer generates the required Boolean equations. It automatically carries out logic and state minimization and store the simplified Boolean equations in an intermediate form. The output of the synthesizer is a gate level logic description. A gate level logic implementation is sometimes referred to as a registered transfer level, register transfer level, that is RTL implementation. This level describes the logical in terms of registers and the Boolean equations are for the combination logic between the registers. Of course, for a combinational system, there are no register and the RTL logics consist only of combinational circuits. So this is the register transistor logic definition. So the main objective of the synthesizer is to synthesize the logical that behaves identically to the simulated behavior of the design description. In effect, a synthesizer translates a design description into a functionally equivalent gate level logic implementation. A synthesizer generates the required Boolean equation. It automatically carries out logic and state minimization and stores the simplified Boolean equations in an intermediate form. The output of the synthesizer is a gate level logic description. A gate level logic implementation is sometimes referred to as a register level implementation, that is RTL. So this level describes the logical in terms of registers and the Boolean equation for the combinational logic between the register. Of course, for a combinational system, there are no register and RTL consists only the combinational logic. This is the half adder synthesis logic. The synthesizer produces the two output files, a BSGL netlist and a technology dependent gate level netlist. The netlist is a textual representation of the interconnection of logical elements. Place and route tool is software used to automatically map or fit synthesized logic to a target PLD's architecture. The place operation selects and configures specific logic primitives in the PLD's architecture for each logic primitive in the technology dependent netlist. The route operation determines the path for each connection between two logical primitives and each connection between a logic primitive and a pin of the PLD. The place and the route tool is usually obtained from the PLD, that is FPGA vendor. A place and the route tool generally produce three outputs: a chip report, a configuration file, and a BSDL timing model. The chip report documents which port signals are assigned to which PLD pins and how much of the PLD's logic capacity is used. The configuration file, that is programmable programming file, contains the interconnection and the configuration data necessary to program the PLD. The BSDL timing model is a file containing a textual style BSDL program that describes the logical and timing of the synthesized logic mapped to the target PLD. This model includes information dealing the propagation delay of signals through the PLD. The complex systems can be described behaviorally at a high level of abstraction so that the description is independent of any particular logic implementation. Alternatively, a system can be described structurally as an interconnection of logic components or subsystem. So VHDL can be used for specification, description, simulation, and synthesis. This eliminates the need for us to learn different languages for different phases in the design flow. Since VHDL is a non-proprietary standard, descriptions are portable to different vendors' tools or to different vendors' PLDs. Previously verified description can be reused in the later designs. So VHDL description for some complex systems can be purchased as intellectual property from IP vendors and include as components in our designs. Because of its wide acceptance as a standard, many EDA tool vendors provide compilers, synthesizers, and simulators for VHDL. So competition between tool vendors leads to the availability of more powerful and low-cost tools. PLD vendors often provide low cost of free EDA tools that include a place and route tool that maps designs only to that vendor's PLD. Because VHDL is a standard, we can use whichever VHDL tools we prefer. VHDL descriptions can be written to be device independent. We can functionally verify our design using simulator before specifying a target PLD to implement them. Rapid prototyping. So this the biggest PLD design methodology can be used for proof of concept to rapidly prototype and implement a system in small quantities to provide its viability. Next is VHDL programming. So before that, we need to know about the comparison between the different model conditions. We will see the one by one. There is behavioral modulation having it consists of sequential programming statement. It requires truth table for design. It represents behavior. It consists of gate level abstraction. It is expressed in the sequential big state process. Data flow. It consists of concurrent statements. It requires Boolean expression for design. It represents behavior. It consists of gate level abstraction or algorithm. The view of data flow as flowing here, design from input to output, and structural modeling. It is set of interconnect component. It requires logical diagrammed for design. It represents structure. It consists RTL abstraction. The view is closest to hardware. So this is a structural concept. These are the points we need to know about these models, that is behavioral, data flow, and structural model for execution. This is the syntax for VHDL programming. So first port end and begin end behavioral is the behavioral modeling.